Great. All right, good afternoon and welcome to Georgia DNR's Lunch and Learn webinar. I'm Emily Wingo with the Georgia Department of Natural Resources Floodplain Unit. First, a little housekeeping. We are in listen-only mode, so please make sure your mic is muted. If you're having the Wi-Fi issues, you may want to turn off your camera and any other programs you have running. Please make note of the chat feature on your screen. Please use the chat for communication as we will not be taking questions by audio. Aaron Kyle of Dewberry is monitoring the chat and will try to help you with any technical matters. We are offering 1 hour of continuing education credit for CFMs. To receive the credit, you must be logged in separately, answer all poll questions during the session, and provide your name and email at the end of the presentation. Please use the radio buttons to respond to the poll questions in either a pop-up window or chat box. A copy of the presentation will be emailed to all attendees. Also, a survey link will be provided at the end of the presentation. We appreciate you completing the survey so that we may improve these webinars in the future. We are recording today's webinar and plan to post the video to georgiadfirm.com. With that, let's get started. Today we have a presentation about NOAA tools and resources, helping coastal communities understand and communicate current and future flood risk. Our presenter is Doug Marcy of the National Oceanic and Atmospheric Administration. Doug is a senior coastal hazards specialist at the NOAA Office for Coastal Management in Charleston, South Carolina. He has been with NOAA for 21 years, working on flooding and sea level/lake level data, decision support tools, and technical assistance. And with that, I'll now turn it over to Doug.
Thank you, Emily. Making sure you can hear me okay.
Just fine.
You're a little
great.
soft.
A little soft? All right, I'm going to get a little closer to the camera. Afternoon, everyone. I thank you for Georgia DNR for inviting me to speak with you today. I am here on camera. This is what I look like. I'm going to go off. I'm turning the camera off in case there's bandwidth issues, but I'll be back on when there's questions and answers. So good afternoon. I am excited to talk to you today about some of the NOAA tools and resources to help coastal communities. I'm going to start out kind of at high level, talking about some of the climate change and sea level rise science that is driving some of the changes in some of our future flood risk. And I'm going to be pulling some of that information from hot off the press, National Climate Assessment number 5, NCA5, which just came out about a month or so ago.
Doug, just a second. We're having a few people who are still saying they're not able to hear you very well. If you can get real close to that mic, we appreciate it.
Okay. Trying to figure out which mic I'm using. Is that better, or do I need to speak up?
It sounds good to me. I'm hoping everybody else can hear you just fine as well. If everybody give me a thumbs up.
Yeah, it's good. They can turn up their volume too.
Okay. Yeah. All right. Well, I'm going to keep going then. One second. Okay. So going over, as I mentioned, we're going to kind of start at a high level, looking at changes to climate that are impacting the flooding that we're seeing going into the future. And then I'm kind of zero in on some of the impacts that are happening in Georgia, specifically with sea level rise and how that is, and extreme precipitation that is changing some of the flooding that we're seeing. And then I'm going to get into some of the NOAA tools that we have and data to help you address the issue. Starting out, we kind of, like I said, at this high level, you are probably familiar with the Governmental Panel on Climate Change, which is the sort of international agency or a group that looks at and does all the climate modeling, global climate models, C.M.A.P. 6, all that kind of stuff. And they put out the 6th assessment report. And this is just some of the highlights that we're seeing, the changes that are occurring. So we've we have the highest CO2 concentration that we've seen in the last 2 million years. We've seen some of the fastest rates of sea level rise in over 3,000 years. Arctic sea ice, the area of the sea ice is lowest it has been in the last 1,000 years, and glacial retreat from both the continental glaciers and mountain glaciers is unprecedented, and it's more than we've seen in 2,000 years. With that, we can also see observed changes in temperature and precipitation in the U.S. This again is from the latest National Climate Assessment. And you can see that in addition to annual winter and summer, we are generally seeing much more increase in temperature throughout the U.S. and then also changes in precipitation too. So when we talk about climate change, we always say kind of that the places that are hot are going to get hotter, the places that are wet are going to get wetter, and the places that are dry are going to get drier. And that's definitely the case. As you can see in the precip maps, you know, some of the places with the browns areas there, that's our areas that are going to also have drought. So you'll have more precipitation in some places and more drought in others. And then going to where I'm going to be spending more time today, especially with coastal impacts, is changes in sea level. We've seen most of the U.S. Increase the number of inches and the rate of sea level rising. Most of those dots are where our tide gauges are. You can see 2 to 3 to 4 inches per decade type of increase. The only places we don't see as much is up in Alaska, where we have the ground, the vertical land motion is actually reducing that amount because there's a lot of tectonic uplift up there. Where are we going to go in the future is really the key to what's going to drive future sea level rise, and some of the other climate factors too. But when they do the climate modeling, they tend to do these different scenarios. They're societal pathways, looking at greenhouse gas scenarios, population, and all that. And the numbers are basically, the higher the number there, the more extreme the scenario. And then on the right, you can see kind of where are we going to be, or the number, the gauge there showing when are we going to potentially see average temperature exceed over 2 degrees Celsius. And obviously the higher scenarios, that's going to be sooner. So if we can keep the emissions down, then we potentially won't get over that 2 degree change. But if we don't, then we're definitely going to see it, you know, as soon as maybe 2042 with a higher scenario. And of course, that increasing temperature is really going to drive a lot of the other factors, especially sea level change that we're going to talk about. This is a complicated graphic, but I like it because it does show how many different variables are at play with sea level change. Globally, the thing that's really driving global sea level rise is the expansion of the ocean as it warms. Anytime you warm a liquid, it expands. But locally, there's a lot of other factors. There's gravitation issues when the ice sheets lose their mass. That's going to change how they're pulling the ocean water close to them. So the farther away from the ice sheets you are, the more sea level rise you're going to see. There's winds and ocean current changes. If the Gulf Stream slows down, the whole East Coast is going to see increases because the Gulf Stream actually pulls water off of the continental, off the shelf, and if it slows down, it increases water levels. We'll also have changes in the in vertical land motion over time. All of those impact local sea level rise. And when it comes to not only the emissions scenarios causing there to be uncertainty with how much emissions we're going to continue to put into the atmosphere and whether we'll reduce that or not, in addition to that, how the ice sheets melt, how fast they melt, the whole processes of how they melt, and calve and all that is really pretty uncertain because we really hadn't seen this happen in our lifetime. So we're studying the glaciers. This is the Thwaites Glacier in Antarctica. This is the one that's been termed the Doomsday Glacier. And of course, the worry is that once the grounding line, because of warming ocean water, Once that sort of fractures, then the whole glacier will start to move out more quickly. But we don't know if that's going to be a linear process or more of a sort of a catastrophic failure. That's why you see a lot of these differences in the scenarios that I'll show you in a minute. So when it comes to the scenarios of sea level rise, you can look back, and this graph shows, going back to the 20s, this is the observed water levels based on averaging tide gauges, and then starting in late about 1993, we were using satellite altimetry as well. And then you can see going out into the future, and based on the different IPCC warming scenarios I just showed you, the SSPs, you kind of see different warming scenarios will result in different sea level scenarios. So somewhere around the middle or the intermediate here, you're looking at around 4 degrees Celsius. So keeping under that 2-degree mark as you can see, is really important in terms of how much sea level rise. And of course, some of that is already baked in what we've got in the atmosphere now in terms of warming. We're still going to see some sea level rise as we're already seeing. That brings me to the science that was behind the inclusion of that sea level information into the climate assessment, which was this sea level rise technical report. It came out in 2022, interagency report, all the different agencies at the bottom there, the logos were involved. The main takeaways from the report is that on the US coast average, we're going to probably see another foot, between 10 and 12 inches of sea level rise in the next 30 years. That's pretty much as we've seen over the past 100. So we've seen about a foot in most places in the last 100 years. We're going to see another foot in the next 30 years. So the rates are obviously really increasing, which that's going to cause more extreme tides. That's going to add to more damaging storm surges because we have more water in the system, and it's going to really cause a profound shift in coastal flooding. In addition, once we get beyond 2050, going out to 2100, there's still a lot of uncertainty, and so we can't rule out these sort of catastrophic failure of the ice sheets leading to upwards of potentially 7 feet. We may not get to that by 2100, but eventually that's a possibility once we go beyond that. And I just want to point out, in addition to the sea level tech report, there's an application guide you can download that kind of leads you through. The technical report is very, very complicated and dense. This is sort of how to interpret that report and use it for local planning. Okay, just want to show that sea level rise, again, is not it's not one number for the whole U.S. It does change based on all the scenario, all the factors I was telling you. You can see from this, we have higher rates in the Gulf, Mexico, mostly because of increased vertical land motion, but all along the East Coast, we do see fairly high rates. Some of that is due to vertical land motion, but also local sea level changes as well. When the science was updated in 2022, we were using some of the previous technical report that was done in 2017. And I just wanted to show you this graph that between the dashed lines there and the solid lines, we are more certain in 2050. And matter of fact, all of the scenarios at 2050 are within 1 foot. So we're increasing our certainty of what's going to happen in the next 30 years. But then when you go out beyond that, there's still a lot of uncertainty based on both the emission scenarios and then the other variables. And this graphic kind of just shows that, like, right now here at 2020, 2022, we're using observed data, but we're also looking at the change. It's becoming non-stationary. In other words, the past is not going to be the key to the present. Things are changing. We're seeing an increase in the rate. The sea level rate is not linear anymore. Linear regression is becoming more of a quadratic equation where it's starting to mimic the curves that you're seeing here. And then once you get out past that, past 2050, there's a lot of variables, and most of that is because of emissions uncertainty, and we don't have a lot of confidence, or we don't understand how the ice sheet are going to react. Okay, that's sort of at the higher level. Now zooming into what's going on in Georgia for you guys. This is the Fort Pulaski tide gauge. It's been there since the late 1930s collecting data. And you can see there's ups and downs throughout that time. You have spikes, and of course that's all like natural variability going on. There are other factors, El Nino and Atlantic Decadal Oscillation, that causes a lot of that. But if you draw the straight regression line through that, you can see that we've seen about 1.13 feet in the last 100 years at that gauge. Looking at that kind of same information here on the red line going back before 1980, you can see it's up and down, and then starting at 2020, we can kind of extrapolate what's going to happen based on that curve. It's starting to not be a line anymore. It's got a quadratic kind of curve to it. So by 2050, we're looking at, somewhere in between the intermediate and intermediate high scenario, somewhere a little bit above 1 foot of sea level rise for the Georgia coast, somewhere in there. And that's going to affect all of our current processes. High tide flooding is already a problem. We just had the fourth highest water level here. I'm not too far away, up in Charleston, South Carolina. We've had the fourth highest water level ever in Charleston from the last storm right there about less than a month ago. And that wasn't even a tropical system. That was an extra tropical sort of winter storm type situation. So we're going to see that starting to happen. And even everyday high tide flooding, which we used to have maybe 2 days average on average throughout the nation, we're going to be looking at 25 to 75 more days, which is almost a 20% increase, or 20 times more, not percent, 20 times more. So that's going to really increase the flooding we're seeing, where we're going to start breaking records all the time. And just to show you, this is the Fort Pulaski gauge. This is a map that shows you what floods, where we start counting high tide flooding days. This is what we call a minor level, that we at NOAA use this level. Every time it goes over that level, we count that as a high tide flood day. And the graph you see there, a little bit small, but going back to the 1920s, or at that gauge, actually it's late 30s, but you can see a really big increase in the number of events, where we're getting up to 15, almost up to 20 a year, where we did not see that in the past. And that's because sea level's rising. And we've built our infrastructure at a certain level, a little bit above mean high water, and that's pretty much been static, but the sea level's going up. Also, the land's going down a little bit as well. So all these factors that we have to deal with current hazards on the coast, storm surge, we have, groundwater, drinking water issues with saltwater intrusion, we have land sinking, all of that's going to continue to happen. But sea level rise is just sort of an exacerbator to the system. It's slowly changing over time, which is changing all of the other processes. That whole non-stationarity is going to start to cause basically the floodplain is going to start marching inland, just kind of like our barrier islands do naturally as it increases. If you look at a 2010 floodplain, 2050, 2100, this is the future flooding, where the FEMA flood maps that don't include climate change right now, at least not the regulatory ones, that is going to change, and that you're going to see an increase in the flooding. Every foot of inundation on flat coast, every increase in a foot can cause over 100 feet. 1 foot could cause 100 foot of inundation, because it's especially on the east and Gulf Coast, where it's very flat. And of course, with other issues with extreme rainfall and coastal flooding in some of our coastal cities, particularly Charleston, Savannah, and others. Savannah is a little different because it's a little bit higher on a bluff there, but many cities, Brunswick would be an example, where you have extreme rainfall and the stormwater systems get overwhelmed. But if the tide and the storm surge is also blocking the outfalls, then the water can't drain. Many of our stormwater systems on coastal areas were not designed to have the sea level be higher, because it's based on a gravity-fed system. So if there's less head on the outfall versus the inlets, then it's not going to drain as fast. And that's forcing communities like here in Charleston, where we're actually having to put pump out stations to force the water out to basically help with that gravity issue. Okay, I'm going to transition now, kind of talking about, sea level rise and projections. And I think we want to do a poll question for you guys. So I'm going to pause there and let them do this. I think they're going to do it through the chat window. So make sure your chat window is open. And I'll just leave this question up here.
So our poll question today is, how many years out is your community planning for future flood risk? And option A is we are not. Option B is less than 5 years. Option C is 6 to 10 years. Option D is more than 10 years. So I'm going to launch the poll now. And if you want to receive 1 hour of CFM continuing education credit, please answer the poll question. Please answer the poll question using the buttons in the pop-up on the screen. And if it does not appear, then please check your chat. And I'm just going to give a few moments for everyone to answer.
It looks like some people are putting the letter response and not doing the chat, not doing the poll, just so you know, Aaron.
Yeah, that's okay. Some folks, sometimes it doesn't show up, especially if they're on the phone, but that's okay.
Okay.
Maybe give like 15 more seconds for a few more responses, and then I'll close up the poll. Okay, and on the screen, we should see the results. So it's pretty good split between all 4 responses. Okay, whenever you're ready, Doug, to move on.
Okay, yeah, that is, thank you all for doing that. It's enlightening for me. I would be, of course, the analytic part of me wants to dive into that a little and unpack it. Like, if you're not, are you a coastal community or are you inland community? That's a pretty big. That's a pretty big spread. So some communities looking like they are going for more than 10 years. Others are not doing that. I'd be interested to know, reasons, but that's not why we're here today. Thank you for doing that. I'm going to continue on if I can here. Let's see. Just give me 2 seconds. There we go. Thank you. All right. So that brings us to some tools and resources and data that we are providing through NOAA. In addition to that tech report, which is available for you guys, it's an interagency report, but it's available through NOAA's website. We also provide a lot of information for the coast, especially. And when I say coastal, even coastal goes pretty far inland for a lot of the data, like land cover and whatnot. So most of Georgia, in some cases, is covered under our data kind of blanket. The Digital Coast is a website, but it's also kind of a community that we have a lot of different partners involved, including ASFPM. As a matter of fact, they've been partners with Digital Coast for many years. We've been at their annual conference, and looking forward to actually, hopefully, maybe seeing some of you in Salt Lake this June. So yeah, we're trying to provide digital geospatial type information to coastal management so that they can enable enabling them to support their resource management. So it's a partnership, but it's also a website, and you can go to, I think I'll have the website on here in a little bit. It's just coast.noaa.gov/digital coast, or you can just Google it. We have all kinds of different things, and I kind of go into that, what's available. We have a lot of data. We have over 500 terabytes of high resolution elevation data, and that's based on, that's LiDAR data. A lot of coastal LiDAR data. All of the Georgia LiDAR data that's been collected recently, we have has been provided, and we make available in our data access viewer. We have we're working on high resolution land cover data. That's one meter. I don't think that's available for Georgia yet, but we're working on that. And imagery as well. We have mapping, web mapping services, and a lot of different national coastal data sets. The data viewer, data access viewer, is one way to get that. So we have sort of a data registry page. You can go in and get different types. If you select like LiDAR data and you zoom in, and you can basically extract the LiDAR data out of the viewer and bring that in for your own use. It's customizable, different formats, different datums. All that can be done through our data access viewer. We have a suite, a bunch of different tools, not just for NOAA. There's other agency tools as well and partners. We have over 50 decision support tools. Some of them are obviously ours, the one I'm highlighting. We have a county snapshots tool I would encourage you to look at, so you can go for your particular county, look at how many people are in the floodplain, look at how many people are and population and critical facility are in different sea level zones. We have a land cover atlas that looks at land cover change. We have historical hurricane tracks, and then a couple other tools I'm going to highlight. We have our sea level rise viewer, which is a screening level tool that's sort of nationally consistent mapping based on the best available LiDAR DEMs. We now have that available at a 3-meter resolution nationally, and we are continuing to enhance that. We do have the new sea level projections, the 2022 projections, in there under the local scenario tab. This is just an example of what that looks like under local scenarios. This is the Tybee Island Fort Pulaski gauge there. You can see that's 3 foot above mean high water, current mean high water, and then you can use the slider there to determine when, you know, by 2080, for instance, under an intermediate to intermediate high scenarios, which we looked at earlier, you know, you can kind of see, we're going to see 3 feet. And that has a lot of implications. We know that our viewer gets used. The Tybee Island Sea Level Rise Adaptation Plan uses it. Obviously, the main causeway, Route 80, going to the mainland, gets inundated even during high tide flooding now. And access for emergency services and whatnot is really important. So I know they're looking at trying to raise that, and they've been using like our data to help with that. New Jersey has taken our data, and they have a whole viewer that brings in our data and overlays that on their local planning data. And we have a bunch of other ones as well that use our data, including the Hurricane Center, which uses our digital elevation models for their storm surge modeling and mapping. We also have another tool called Adapting Stormwater Management for Coastal Floods. This is the issue I was talking about with a lot of the coastal stormwater systems were not designed to deal with incoming tidal water at the same time as trying to drain fresh water. So there's a tool here that kind of lets you specify your own threshold, and we'll start to give you information on when is the threshold you selected, when is that going to start to happen, like daily, you know, as things change, and it gives you a year and it helps with planning horizons. We have another tool called the Coastal Flood Exposure Mapper. This is zoomed into Georgia. What this is sort of a composite of all the different coastal flooding possibilities, including high tide flooding, the FEMA flood zones, tsunami, storm surge, sea level rise. And what it does is allows you to zoom in, and you can select a location, and it tells you the number of hazards you're exposed to. So if I click here somewhere, it tells me I'm in a FEMA flood zone here. I'm going to be impacted by potentially 1, 2, or 3 foot of sea level rise. I'm in a category 3 storm surge zone, and I'm also in a high tide flooding zone. So the closer you are to the flooding source, the more types of hazards, the ones that are more frequent, as well as the ones that are more extreme, less frequent. We also have an academy for learning. We have 190 learning resources, classroom, online trainings. We actually do a 2-day inundation mapping course. We partner with usually the National Estuarine Research Reserves, or sometimes with universities that has a GIS lab, and we'll do a two-day GIS training on how to do inundation mapping and all the data sources. A lot of those are online, self-guided, including we have one that you might be interested in, which is Introduction to LIDAR, which is a good course. We have a lot of different stories. We call them stories from the field, but they're essentially case studies throughout the country where folks have used our Digital Coast data and resources to address a coastal issue. So our motto is not just about the data, it's how the data is used or can be used and leveraged. And then we also highlight the partnerships that were involved in those projects as well and what the impact was. Lastly, we have a bunch of topics. I focused in on this one. We do have a coastal inundation topic, and it's all the resources I was talking about earlier are available through that. There's a ton of stuff. We try to keep it pretty fresh. So I encourage you to go in there, and all the sea level tech reports, all that stuff is in there to link to. I'll just point out one other thing that we're working on, NOAA, and partnership with FEMA, HUD, and White House, which is the Council of Environmental Quality and Office of Science and Technology, are working on a federal flood risk management decision support tool. We're right now in an federal agency review of that tool. It's GIS based, will allow us to do climate informed science approach for at least the coastal areas for now. Riverine is going to have to be still use a freeboard approach. But this tool, hopefully, we don't have a date yet for launch, but it's sometime hopefully in this new calendar year, February timeframe. And the idea here is, the 8-step process agencies use that they used for Executive Order 11988, which is don't try not to build in the floodplain, but if you have to, there's a 8-step process to go through. Well, this tool will help agencies and grantees that get money from federal agencies like highways and whatnot determine if they're going to be in the future floodplain. So FEMA's actually been working on developing a library of maps based on the current BFEs and extrapolating into the future, and that data is being ingested into the tool as we speak, and eventually we're going to have coverage for everywhere there's digital flood insurance rate map information now. Okay, I went through that fairly quick. There's a lot of information slides. I'm going to share the slide deck so that can be shared with you guys. This is my contact information. That's just doug.marcy@noaa.gov. If you have any questions, I can point you to any resources. And with that, I'm going to leave the final slide here, which is, well, maybe I'll let you guys talk about the next one, and I'll stop there for any questions.
Great. Thank you, Doug. We do have a question in the chat. NOAA Digital Coast provides some great tools and training. Does your office offer help to coastal communities in their planning for sea level rise?
We do. Thank you, Bruce. I paid Bruce to ask that question. No. We do provide technical assistance as well. So a lot of times we will get I'll give you an example. Okay. Jennifer Klein works with the Coastal Zone Management Program in Georgia. And when she has questions about sea level projections, or if she even wants, someone to come talk, and I just recently did come down and talk to the coastal management. They have I guess it's Coastal Resource Council or something. I can't remember the group, but about some of the sea level science. And I get questions a lot of times like, what do you think about this and that? And so yes, we do. We provide technical assistance. We recently put out Climate Resilience Challenge grant program opportunity. And that's all about, from some of the bipartisan infrastructure and IRA, that's the Inflation Reduction Act funding, so that communities can, apply for that. But then part of that is NOAA, our office would have help with technical assistance to implement that, whatever the grant application was going for the projects. And a lot of that was if there was already a program kind of already developed, this was for money to basically try to implement that. And if there's anything we can do on our end for data and technical assistance, that'd be part of it in the grant, and as part of the grant opportunity. So. Oh, Atlas 15. I didn't mention it, Bruce, but yeah, I don't have a slide on that, but I can tell you, if you Google NOAA Atlas 15, because I've actually done this, there's a 2-page document that Weather Service has available on the status of that. Not only 15, but Atlas 14 is being updated too. Atlas 15, if you're not familiar with that, folks, it's sort of the Bible for rainfall analysis when you're doing flood studies. It's the 24-hour rain event that comes from Atlas 14. What they're doing there is using some bipartisan infrastructure law money. They're updating that to include climate impacts, which would be the non-stationarity that we may see with future rainfall. So they're updating the IDF curves, and that is supposed to be coming out in 25, I believe. And I think they're going to start by doing some pilot areas, maybe in Montana and some other places, is what I've heard. But looking at how, precept may change over time and how that would affect the design when you're starting to do, and also for flood studies. So. Anyway, the group that's leading that effort is the Weather Service. It's the National Water Center, which is out of Tuscaloosa, University of Alabama. If you want, you can get in touch with me and I can put you in touch with those folks.
Great, appreciate that. I did notice on your website when you were mentioning some of the training that is on the Digital Coast, that there are a lot of good trainings for either in person or on a webinar format like this to help some of these communities in learning how to talk to their constituents about sea level rise and future conditions of what's coming out and precipitation data. I think there was one coming up at the end of the month, and I just wanted to give y'all a plug on that one as well for those coastal communities that might be interested in that. I know the link will be included in this, but just to help folks out, because I know there's a lot of outreach that has to go out to folks and get people to understand precipitation data and future forecasting of precipitation data as well. So I appreciate you mentioning Atlas 15 as well. And Bruce was kind enough to throw the link in the chat for folks.
Yeah, thank you.
We also had mentioned, someone mentioned that the Georgia Cooperating Technical Partners, our office, has been producing freeboard grids for the majority of their flood studies to help folks out. And these are, of course, non-regulatory products. But do you see going forward how Atlas 15 and other future forecasting of precipitation and sea level rise will impact those non-regulatory or regulatory products that floodplain managers are using?
Yeah, short answer is yes. Like you said, a lot of states are starting to produce their own, forward-looking, or I mean, many states use freeboard already. Part of the carrot is the community rating system, right? So you go above and beyond the standard, and you get some credits for your insurance rates. And so, like, the federal flood risk management standard is really just trying to keep up, the federal government just keeping up with what the states are already doing, which is that you need to do a 2 and 3 foot freeboard. The climate approach really for coastal is basically that acknowledging that sea level rates are not the same everywhere. So a 2 and 3 foot freeboard for everywhere in the U.S. Isn't, maybe doesn't make sense, especially maybe by 2050 we may not see 2 and 3, we may see 1, but eventually we're going to see more than that. But I also know, FEMA, yeah, they're developing kind of that freeboard library. It's going to be non-regulatory. It's a way to start to show, we know scientifically, it's more complicated than just adding 1 foot above the base flood, right? Because there's a lot of dynamic things that happen. Theoretically, you'd want to include that elevation into the beginning of the modeling. But I do know that the folks in FEMA on the coastal side, at least, they're working on, well, I think riverine too. They're working on more of a probabilistic type mapping product that is not just in and out. National flood hazard layer right now is either the 1% or the 100-year and then the 500-year. This would be more of a graduated band of risk. So the closer you are to the flood source, obviously the higher frequency you're going to be impacted, right? So what that's hopefully going to do is influence the risk rating 2.0, which is not necessarily right now connected to the DFIRMs, but what we're hoping is an individual structure risk would be based on more of a refined probability than just in and out. And that's going to require doing better with not only the extremes like the 100-year or the 1%, but also the higher frequency events. So that's something NASA, or we're working on with FEMA, and is how to, like with the high tide flooding, things that are happening on a more frequent basis. Most of the flood studies don't really calibrate to lower events that are higher frequency. They usually do the 50-year and 100-year. So we're working on that sort of space to get better information in there, so we can do that, work on that full probability spectrum. I mean, it sounds a little technical, but what I'm getting at is it'll hopefully inform more than just your in and out. And then if you start looking at sea level rise and changes in precip, you can see how that current frequency is potentially going to change over time. So maybe like the 100-year becomes the 50-year and that kind of thing in the future.
Wow. Bruce wanted us to mention that you have several stories and examples on Digital Coast website. Any communities like maybe Tybee Island come to mind that you'd highlight that have taken a proactive approach to the SLR based on or using NOAA Digital Coast information?
Yeah, well, that's the example that I pointed out. Tybee, they working on their sea level strategy, looking at not only the visualization, and I think they've used our viewer to kind of show that, spatially, this is what's going to happen. Yeah, the causeway gets cut off at like 2 or 3 feet, and this is going to happen, by 2060 or 2050, this is going to be underwater all the time. I mentioned New Jersey. They have a New Jersey ADAPT program. Then a lot of different states have used our data, because they're starting to look at, what potentially is going to happen in the future. Some even are like California are building that into into the regulatory component, where they're like executive orders saying you have to use a certain sea level projection for going forward. I think Florida's starting to do the same thing, where they have to go through and for big planning projects, they have to include some of the scenarios in there too. So yeah, I would encourage folks to go in that stories from the field. It's not comprehensive, but it's a good example of how folks have used our data.
And just to plug the other story that's from Georgia, you also have one for Camden County, I believe, and Glenn County, where you where you work together with Georgia DNR's Wildlife Resources Group and Coastal Resources Group in using some of this data to help inform best ways to help wildlife as well. So yeah, those are great.
Like I mentioned, we're very much in touch with the coastal management program that's been doing a lot of work with Skidaway folks too. Clark Alexander, they're looking at marsh modeling and marsh migration and running the SLAM model, and eventually, if we have high resolution land cover, 1 meter, that we could really improve on that analysis. So
fantastic. Again, there's some more links in the chat for anyone who's interested in learning more about what we've talked about today. And I'm going to thank Doug again for all of his wonderful work that he's doing and the information that can lead to help all of us on the coastal level, as well as eventually in the riverine. I hope everyone else has enjoyed this presentation as much as I have. We're going to keep the chat open just a few more minutes in case somebody else has a question. Please be sure to include your email address along with the question so we can make sure we follow up with you. Also, I need everyone to mark March 6th from 1 to 2. Note that's a different start time on your calendar for our next Lunch and Learn webinar on environmental justice, how we change so everyone thrives. Please make sure you note that's from 1 to 2. Also, please make note of the survey link, and we'll be posting that in the chat as well. We appreciate you completing the survey so that we can improve these seminars or webinars in the future. We are offering 1 continuing education credit for today's session, available only to certified floodplain managers that completed the polling questions and provide their name and email in the chat now. A copy of the presentation will be emailed to all attendees. If you're requesting continuing education credits, those certificates will be emailed separately. Once more, our next Lunch and Learn is scheduled for March 6th from 1 to 2, so be on the lookout for that invitation if you didn't grab it out of the chat. For those who don't have any other questions, this ends our Lunch and Learn webinar. Have a great day, everyone, and thank you again, Doug.
Thanks, Doug. Greatly appreciate it.